Hi, my name is Madhav Mekla. I'm from PepsiCo. I oversee the architecture at Pepsi Foods North America, which consists of Frito-Lay and Quaker brands. I want to talk about a complex order-to-cash app that we are developing right now and how we are using Couchbase to power the app. I'll give a brief background of the app, the business side of it, and then show you how we are using Couchbase to enable the functionality. So a lot of times we get asked saying, why do you modernize? So this is basically we are modernizing a current system with a much better platform. So this journey is to transform into the new digital transformation with newer devices, newer architecture, and then more flexible architecture. So why did we choose to modernize is a question that we get asked a lot, right? So the current device that we have is used by our frontline sales people to do all their activities throughout the day in the stores. So that is almost a 2 decades old device, and we are having a lot of issues with some stability, memory issues on the device. One of the primary impediment there is it uses 3G as the connection cellular technology to connect to our backend systems. 3G is being retired early next year. So we have to have a solution to be able to have the device connect to newer technologies like 4G and 5G, but the current device doesn't have the capability. So we definitely have to move it to a newer device like iPhone. That's one of our primary reasons why we're modernizing at this point, but there are other reasons as well. Frito-Lay has a storied history of 100 years. We have built optimized business process throughout the decades to maximize the sales. So there are multiple business models how we do sales, like how we write orders for a large format compared to a small format, how we deliver products in rural areas compared to urban areas, how we actually deliver the product to regular stores using our own people was compared to a large stores like Walmart or Costco, where we directly deliver to the store from our plant. So there are various business models, and this app that we have currently in production is purpose built to support all those business models. So it's a legacy app, it is a monolith, and it's hard to change. So now business wants to enable new business models or new ideas that they want to bring to life, and it's very hard to change the existing system. So we need to move to a new modular architecture, and it has to be very flexible so that we, in a very agile fashion, we can bring new ideas to life. The time to market should be much, much less with the new system that we're building. One other thing that we want is have a full connectivity to the user. So the data can be updated in near real time so that the user has always the latest data. Also, when we place orders or other documents, we need to be sending them to the backends as soon as possible so that we can start fulfilling them. In addition to that one, we also want users to be in constant communication with their managers to be able to efficiently do their work. So the current system is not that connected, so we want to move to a more connected system. On top of that, we also want to use the latest features like of iPhone, be it using a lot of the sensors that they have, the virtual reality features that they have, scanning, Bluetooth. There are many others that the new devices provide where the current one doesn't. So we want to move to these to be able to leverage all those capabilities and build a much better user experience for our field. And we also have a lot of third-party specialty apps that we want to connect to, which we cannot do in the current app. So if you see, there are a lot of shortcomings in the current one, which we want to address, and that's the reason why we're modernizing. Again, I just want to give an overview of what is the process that we are trying to do here, right? So it's a typical order-to-cash application. So where our sales reps go to these stores, they create orders on behalf of the customers. Those orders flow into our backend systems. There is order cleansing, order management that happens to make sure all the products are correct. And then the picking happens in our warehouse systems. Then our sales force, the salespeople take that orders, deliver them to the customer. There is a customer check-in process. And once the invoice is finalized, is basically goes into our AR systems, and then the financial posting will be done after that. It's a typical order to cash process, but what we have is there are a lot of processes in this which are very specific to Frito-Lay, and that's what our app supports the frontline users to do all those activities in this whole process that are to be done in the store or that are to be done in the distribution center, and it enables the users to do all those tasks, right? So now that you know a little bit of the process, we want to see what the app actually, the capabilities of the app are. On the left side, you are seeing the current device that is in production, which is an Intermake Windows-based device. Again, it works very well. And I talked a little bit about some of the shortcomings. But again, it has been time-tested, works well, not many incidents from the functionality perspective, but the whole hardware itself is coming to end of life. That's why we want to move to a newer hardware. The functionality includes scheduling. So the sales reps can see the schedule, where to go, which stores to stop, what activities to do within the store. All that is scheduling data that we get from Salesforce into our app. There are other things that they do, like create orders. There are different types of orders that they can create. So all that, again, it depends on the type of customer and what is allowed, what is not allowed. There are a lot of nuances to it. And then the delivery. So when we deliver the products, we need to create the invoices. And again, that has multiple ways using decks or other things that we have to deliver. So there's a lot of complexity in there as well. The users will be able to track their time, enter their time card in this application. They're also able to do a lot of retail execution. So in the store, there are a lot of other things other than ordering and delivery, where they have to set up a display or other activities that they have to do. And this app should support all that retail execution as well. And then again, as they're selling and ordering products, they need to make sure the inventory is right. So all the inventory management also happens on the app. And in addition, there are reporting and the analytics, the various things that we have the users to look at them and then make the best decisions to do more sales. So in short, it's basically a small ERP that we are building on a device. And it's just to show how complex this app is, right? Now, from an overview, I want to show a little bit on the features that we are developing on this app. So it supports full functionality, which has about 1,200 screens. I mean, just let that sink. It's 1,200 screens, and some of them are role-based. So some people can see some screens while others can see other screens. So it's a huge application. And again, it supports all the business process I was talking about, like whether it is small format, large format, we deliver, or it is direct store delivery. There are so many other processes that this app supports as part of this 1,200 screens. We also want a fully offline capable app. So a lot of times when we go, our sales reps goes into stores, those are all metal buildings and there's no connectivity there. There's absolutely zero connectivity, even in an urban area. So we need to have all the data that they should be able to do in the app stored on the device itself, so that they can complete all the activities within a store. And in some rural areas, they don't have any connectivity throughout the day. And the only connectivity they have is at the distribution center, where they start the day and end the day. So for those, they get the data in the morning and they have been able to run the whole day without any connectivity. And then when they come back, when it connected, we want to sync all the documents back and forth. And again, during the day, if it gets a connection, we want it to be near real-time sync, so that we can optimize our supply chain systems so that as soon as the order comes, we can start fulfilling them. We also have requirements that are fulfilled, that we use other third-party apps, be it labor management, CRM, DOT compliance. So there are specialty apps for those. So we did not want to build all that functionality ourselves. So we are using those apps. And the beauty of having an iPhone is we can build an anchor app, which is ours, and then we can seamlessly transition to all of these apps without relogging. I mean, we can use deep links and then try to get all the relogin. We also have the reps also carry multiple peripherals. So they have a Bluetooth printer so that they can print the invoices. They have iPhone scanners so that when there is an order, they can scan the products so that they don't have to enter all the UPCs. It's a very big time saver. And also in some stores where they support DEX to send all the invoice data to the customer's backend accounting systems, we support DEX as well. And that runs on BLE, low energy Bluetooth. So the app that you're building needs to support all of this. And in addition to that one, we also want to send only the data that's applicable to a particular route. Like if I'm a user and I'm responsible for 30 stores, I don't really need data for any of the other stores. I just need the data so this optimizes the sync times and it only gives the information that they need so that the app is much faster. All the subsetting is provided by Couchbase. So we have the whole data in the backend, but when I sync from my device, I only get the data that I need. And this is managed by assigning the right channels in the Couchbase sync server. And that's primarily why we are using the Couchbase sync. So I'll get a little bit into the architecture as well. So, and this is the high level architecture where on the left-hand side, you see the app, which is built on Xamarin. And then it has a CB Lite database embedded into the app. So all the data from the offline requirements, we get all the data from the CB Lite. We have a robust server, massive infrastructure on the server to support tens of thousands of routes that we'll be deploying this application to. So the first line of defense would be all of our gateways, the firewalls, load balancers to make sure only the authenticated requests come in and we do all the checks before we let the traffic into our backend systems. So sync gateway is again is the main component here that we integrate with the device into our backend, and the sync gateway will basically knows which ones are already synced, which ones are not, and it basically sends data back and forth to the device and keeps the device up to date with the server. So, and then we do have requirements of a few things where we have to directly call sync APIs. So that's where you see the sync API layer on the top, but it's accounts for less than like 1% of all the data flow. Most of the data, 99% of the data goes through our CB sync gateway. So once this CB sync gateway syncs to our backend Couchbase cluster, again, it's a massive cluster that we built on our backend on Azure. We have a layer of integration APIs that basically takes the data from the Couchbase cluster and then it sends to our backend systems. A lot of them are on-prem, which are ERP systems, ETLs, financial systems, and others. So there's a lot of integration that is needed for the documents that are coming from the device to the backend. In a similar fashion, all the master data that we need to send to the device is integrated from the backend through the integration APIs or the microservices into the Couchbase cluster. And then that's where the CB sync gateway will do its magic to send the right data to the right device. And that's how it keeps in sync. And Delta Sync, the new feature on CB Sync, is helping us a lot, cutting down our sync time by more than 90% compared to our existing device. So this is the reason we wanted to transform this into the new architecture and then modernize the whole application. I'll also give another example where we modernized our application, and again, Couchbase played a part in that too. When COVID hit, we were always, Frito-Lay as a company always sold to stores, and the stores sold to consumers. But there was a lot of demand for online shopping at that moment, right? So people were afraid to go to the stores with a lot of supply chain issues. There were no products in the store sometimes. So we basically built a website where a D2C website where consumers can come directly and place orders within 30 days. So as soon as we saw an opportunity and say, hey, we need to solve this problem for our consumers, we basically stood up a site within 30 days, an end-to-end integrated system, and it's called snacks.com. And a lot of our consumers were able to directly order through our snacks.com platform and then get it shipped to their home. And then once we were able to do that, we enabled new business models on top of that, like make your own multi-pack, holiday shops, and a lot of other functionalities within a short period of time. So we want to do a similar thing here. So we want to basically take the legacy device, put it on the new iPhone. And once we have this new platform built and deployed, then we can deploy a lot of new business models and business ideas on top of it and test it. So just want to show you how Couchbase is the central piece to this whole transformation. And we really like the product, what we are seeing right now. So I thank the Couchbase to giving me an opportunity here to present. And if you have any questions, please reach out to me. Thank you so much.